Hi everyone. Myself Hamaz Hashim and my teammate Akhil Sebastian is going to present a seminar of the topic explosion welding. So these are the contents of our presentation. First, the explosion welding, then the components of for welding, then the principles of explosion, placement of cladder metal, explosive material, application, industries using explosion welding, examples, advantages and disadvantages, and then the references. So first, what is explosion welding? Explosion welding is a solid state process that produces a high velocity interaction of dissimilar metals by a controlled detonation. This explosion welding eliminates the problems of heat effects and microstructural changes. Oxides found on material surfaces must be removed by effacement or dispersion. Surface atoms of two joining metals must come into intimate contact to achieve metallic bond. And next comes the components for welding. At first, we will talk about the base component, then the cladding metal, then the flyer plate, then the interlayer, anvil, and at last the standoff. The base component is joined to the cladder. It remains stationary, that is, it is not in motion, and the base component is supported by anvil. And then the cladding metal. Cladding metal is a thin plate in the direct contact with the explosives, and it can be shielded by the flyer plate. Then the flyer plate is a sacrificial plate which is placed between the explosive material and the cladder plate, which is to protect the cladding metal. And the flyer plate is used to protect the cladder metal. Then the interlayer. Interlayer is thin metal layer. It enhances joining of cladder to the base plate. Then comes the anvil. Anvil is the surface of which the backer rests during explosion. And at last is the standoff. It is the distance between the cladder and the base plate before explosion. Next is the principle of explosion. First, the cladder metal, it can be placed either parallel or inclined to the base plate, and the explosive material is distributed over the top of the cladder metal, and upon detonation the cladder plate collides with the base plate to form the weld. And the mechanical bonding joining takes place due to the generation of the waves. A single detonation cap can be used to ignite the explosive. So in this figure we can see the base plate at the bottom, and we can also see the flyer plate, and the distance between the base plate and the flyer plate is called the standoff distance. And on the top of the flyer plate there is the buffer plate, and the explosives are also taken in the top of the buffer plate, that is the cladder plate. So here the cladder plate is kept inclined, and when the welding starts, the explosion takes place at the bottom of the cladder plate, which can be seen in the figure. So next is the placement of the cladder plate. So the standoff distance, that is the distance between the cladder plate and the base plate, is predetermined, and it is unique to the material combination, which is achieved by placing shims between the plates. The shims is designed to be consumed by the explosion wave, and that is the shims does not affect the welding. And the shims usually ranges between 0.5 to 2 times the thickness of the cladder plate, and the cladder must reach critical velocity before the impact. So in the figure we can see the base component, and there is the prime component, that is it is the cladder component, and on the top of it we can see the explosives which is kept, and there is the detonator which is to initiate the explosion, and the distance between the base component and the prime component is called the standoff distance.
Explosive material. There are two types of explosive material. First one, it is the high velocity, and second one, it is the mid-low velocity. The high velocity is in the range of 4572 to 7620 meter per second, and the mid-low velocity is in the range of 1524 to 4572 meter per second. And the high velocity contains TNT, RDX, PET, datasheet, and Primacord. In mid-low velocity, it contains ammonium nitrate, ammonium perchlorate, amatol, nitroguanidine, dynamite, diluted PETN. So the applications: cladding of base metals with thinner alloy. Example, cladding of TI with milled steel. Seam and lap welds, reinforcing aerospace materials with dissimilar metal ribs, heat exchangers, tubular transition joints, used as a repair tool for repairing leaked tube-to-tube sheet joints, spot welding, flat plates, joining of pipes in stock joints. Industries using explosive welding: chemical processing, petroleum refining, hydrometallurgy, aluminum smelting, shipbuilding, electrochemical, oil and gas, power generation, cryogenic processing, pulp and paper, air conditioning and chillers, metal productions. So these are the examples of explosive welding. And next one, it is the advantages. It can join both similar and dissimilar materials. Simple in operations and handling. Large surface can be welded in single pass. High metal joining rate. Mostly time is used in preparation of the welding. It does not affect on properties of welding material. It is solid state process, so does not involve any filler materials, flux, etc. So next one, it is the disadvantages. First of all, it can weld only ductile metals with high toughness. It creates a large noise which produces noise, pollution. Welding is highly dependent on the process parameters. Higher safety precautions involved due to